I'm just going to wait for the microphone to chill. Maybe for like 5 more seconds, I don't know. Hopefully the microphone is working. Every single video has been the craziest sound at the beginning. I don't know what's going on. I'm sorry about that, guys. I'm using the little like document camera we have in class for the microphone because apparently a Mac does not have a freaking microphone on it. But anyways, so for this problem, now remember the whole point of proofs. So if you're doing a proof, think back to Uno. So let's see, I have some Uno cards right here. Maybe I can make us an example. Alright, now the reason we played Uno in class was because in Uno, if you lay out a card, if this was the card that was in play, and you had another card, let's see, what's another good one? Here we go, perfect. So if I started with a blue 9, like, I'm sorry, red 9. If I started with a red 9, and I had a blue 5 that I wanted to get to, what card could I play in the middle, excluding wild cards, right? What card could I play in the middle that would make a bridge between 9 and 5? Well, I'd have to pick something that had something in common with a red 9 and something in common with a blue 5. So in Uno, I would play the blue 9. The blue 9 has the 9 in common with 9 and the color in common with blue. Or if you're colorblind, it has a little square in common. Pretty cool, right? So mathematic proof is the exact same way. It's the exact same way. You make these steps you start with and end with, and then it's up to you to play a card that connects both of them with some kind of reason. Okay? So think of, as we continue with proofs, think of them like that. Like a puzzle, you have to fill in as you go. So, guys, if you practice proofs, they become so fun. They become just like a puzzle. Just like the Wordle or something, right? Okay, anyways. So right now, we're given that these lines are parallel. So whenever I get a proof, I like to draw in what I know. So over here, I'm going to draw in this line is parallel to this line. Okay? So let's see. The measure of angle 4 is congruent to the measure of angle 5. That's improper notation. This should be equals. The measure of angle 4 is equal to the measure of angle 5. So the measure of angle 4 is equal to the measure of angle 5. This is my goal. I want to show that these are the same angle. That is the goal. So let's see. For my first statement, I know it's going to be this one. That L, the line L, is parallel to the line M because it's given. This is my start of the proof. Okay? Now, I can't jump directly. Now, these are alternate interior angles, and these are parallel. So normally, you could just say 4 is equal to 5 immediately, because they are alternate interior angles. Except that this problem explicitly tells us not to use the interior angle postulate, the alternate interior angle postulate to solve it. So, instead, we're going to have to find a way around it. Now, there's a ton of ways around actually using the alternate interior angle postulate itself. I'm going to do the easiest way, which, in my opinion, is to say something like, let's see, well, 5 and 6 are supplementary. 4 and 6 are supplementary. And so since 4 and 5 are both supplementary to the same number, they must be equal. Okay? Here's how we're going to show that. First, I'm going to say what I just said. I know that the measure of angle 5 plus the measure of angle 6 is equal to 180 degrees. They're supplementary. They're a linear pair because, they add to 180 because they're a linear pair is what I might say. So since 5 and 6 are a linear pair, they must add to 180. That must be true, right? Okay. Now, I also know the measure of angle 4 plus the measure of angle 6 is also 180. Now notice, I knew in this case that I needed the measure of angle 6 in this equation because that's the thing, like in Uno, that's linking me to the previous card. So here's my previous card right here. I had to have something with measure of angle 6 in it so that it would link to this. Oh, I just smeared the ink everywhere. Okay, but that's the basic idea. And the reason for this is also linear pair. So since it's a linear pair, I can say these are 180. Okay, nothing crazy yet. Now, I need a way to link 4 and 5 in the same equation. If I do, I could show that they were equal. So to do that, I'm going to move over the measure of angle 4. I'm going to subtract, because the measure of angle 4, we don't know it. We're just treating it like a variable, treating it like x. I'm going to subtract the measure of angle 4 from both sides. So I get the measure of angle 6 is equal to 180 minus the measure of angle 4. Pretty cool. And this is just by algebra. Here's my next step. Alright, now by substitution, I'm going to take this piece that I now know plugs in for measure of angle 6, and I'm just going to write all my steps out right here, but I have measure of angle 5, that's this right here, plus, and then in this equation, I'm rewriting it as this though, 180 by substitution minus the measure of angle 4, okay, close parentheses, equals 180. Beautiful. And this is by substitution. And this is from Algebra 1, I might say. We learned how to do substitution in Algebra 1, so that's kind of where we're doing it from. Now, I could subtract 180 from both sides. So really, since we're just adding these parentheses, and there's only, since we're adding on the parentheses, and there's no multiplication going on inside these parentheses, it's okay to just be like, alright, well, let's drop them off. We don't need them. Okay. So ignoring those parentheses, I'm going to subtract 180 from both sides, and then add the measure of angle 4. Okay, so minus 180 plus the measure of angle 4. And then I'll have the measure of angle 5. And then here, my 180 minus 180, that cancels. Measure of angle 4 cancels. And then here, 180, 180 cancels. And I'm left with equals measure of angle 4. Beautiful. So, measure of angle 5 is equal to the measure of angle 4. That's exactly what I wanted to show. So we're done. And this is also by, I'm just going to say algebraic simplification, you might say. Alright, so the measure of angle 4 is measure of angle 5, and we're done. QED. So you can draw your little square, maybe write QED in bold, something like that, to show you're done. That's your proof. Alright, cool. So for this next one, I'm also going to show the next proof in this same video, so don't skip out yet. Describe the relationship between the corresponding angles postulate and the construction of parallel lines. This is something you should definitely know for the exam. And basically what I'm going to say is, in class we had a problem like this the day we made soccer balls. We had a problem kind of like this, where we had a point P and a line L, and we were like, let's draw a parallel line through P. So we drew a little arc. This is in the last notes. We drew an arc here. We then used the compass. I'm not going to use it right now, but we used the compass to copy this arc over here by seeing the distance they were. And we realized, hey, if we use corresponding angles, we can fabricate a parallel line. So what I would say here, the answer to this question truthfully is corresponding angles can be used to create parallel lines by corresponding angles can be used to create parallel lines because by their respective theorem is what I might say. Look at this answer. It's clean and concise and uses few words, and it has a picture supporting what I'm actually saying. If you had a problem like this, this is a perfect answer. I can look at your picture and see the corresponding angles and be like, oh my god, he's right. These do have to be parallel. Look, he drew it. They have to be parallel. And then you can write down here something like, corresponding angles can be used to create parallel lines by their respective theorem. This is like corresponding angles have their own theorem that makes these lines parallel. Okay? So on the next page, for this last proof, alright, same business. Something cool happens. So given, we're going to start it with what we're given. Measure of angle 1 plus measure of angle 3 is 180. That's given. For sure. Alright, and 1 is congruent to 4. Alright, so we know, I'm just going to draw this in. We know this angle is equal. I'm sorry, just kidding. That's what we're trying to show. We're trying to show that 1 is equal to 4. We know that 1 and 3 are supplementary. So, if 1 and 3 are supplementary, that would mean we're going to use the same trick, I guess I should say. If 1 is supplementary to 3 and 3 is supplementary to 4 because they make a linear pair, then that means 1 must be equal to 4 because they're both supplementary to 3. So I'm going to write out, this is very, very similar to the last one. I'm going to write out the same exact thing. So we know 1 and 3 is 180. We also know 3 and 4 is 180. Perfect. And this is by linear pair. Awesome. Alright, now there's my link of the Uno card. I'm going to do the same thing. So my next step would be if I algebraically move this over, I could know that the measure of angle 4 is equal to, the measure of angle 3 is equal to 180 minus the measure of angle 4, just like we just did. Now I plug in angle 3, measure of angle 1 plus 180 minus the measure of angle 4 is equal to 180. And this is by, I'm just going to write algebra here and algebra here. Alright, and guys, truthfully, if you just did this on the test, like, okay, for example, like if you just did this on the test and it took you forever, don't do it again. Draw an arrow and be like, hey, I just did this. Write in the reason, just write in your justification, I just did this on the previous page. Or like, look at my previous work. Something like that, okay? I know what you mean. I can turn, I'm a human being, okay? I'm not a robot. I can turn the page over and see your work so you don't have to show twice as much work for the same kind of problem, okay? I'm just doing it again here to be thorough. I'm just trying to be as thorough as possible. So if you want to be as thorough as possible on the exam, then of course you're welcome to do every single step you want. I'm going to read every single step you write. But you don't have to. So same thing, I would cancel 180 and measure of angle 4 to get the same thing. Measure of angle 1 must be the measure of angle 4, and that's by algebra. So look, in this case, all your steps are really algebra. Okay, and this is the result, so I'm going to write QED to show we're done with the proof. The result has been shown. All of our reasons make sense. All of our steps make sense, which means our result has to be for sure proven. As you guys can hear, that's the bell for tutorials. I finished just on time. You know me. Make sure you're studying for the exam that's coming up, guys.